Okay, so here is the, you can take out your review sheet. The first problem, which is try to sketch the graph or sketch the graph of y f of x equals 0.5 to the x, right? This one, right? So this is the exponential function. So we have to use the, we can pick several points, right? If you want, and this is the x values, and this is the f of x value, right? When x equals what? Equals, we can take 0, right? This is the one point that we must take. Then 0.5 to the 0, which is equal to 1, right? This is the one thing. And we can also take equal to 1, right? And 0.5 to the first, which is equal to 0.5. Right, this is the second point. So this is 0.01, and this is the 0.1.5, right? And then you have pick -1 because this is the fraction, right? This is a point, a decimal number. We can take it as some -1. So -1, 0.5 to the -1. You can use your calculator. It would be equal to 2, right? 1 over 0.5, so it's equal to 2. So this one point is -1 and 2, right? So if you have draw the graph, sketch the graph, okay, sketch the graph. So it would be 0, 1 is here, for example. This is a 1, so this is a 0.5. So and 1.5 is here. And -1, this is -1, this is 2, right? So it would be here. Right, so the graph looks like this. Not good. We should not touch the x-axis. Okay, so the graph for, because this is the base is 0.5, which is less than 1, so the graph is always decreasing function. Okay, if the base is greater than 1, it would be increasing. It will go the other way, right? This is for the base b greater than 1, and the base less than 1, greater than 0. This would be, sorry, this is the would be this one, right? This graph, this kind of graph. So you should make sure the base is greater than 1 or less than 1, right? And the domain from this graph, the domain is all the x values, right? That you can plug in. So you can see from the graph, you can plug in any x values you want, right? So if domain is -1, -infinity to +infinity, all real numbers. Okay, and the range is the y values for this curve, which is greater than 0, right? Which is always above x-axis. So the range is y greater than 0, or from y belongs to what? This is from 0 to +infinity, right? So this is x belongs to, because this is the domain. Domain is about x input. The y, the range is about the output. Okay, so this is this problem. Second one. We want to convert 2 to the third equals 8 to the logarithmic equation. Okay, so this is we have, when we studied this one, we know that there is a equivalent form for the logarithmic equation, which would be what? Which is 3 is equal to log base 2 of 8, right? 8. And 3. Which is, we want to convert the logarithmic equation to exponential equation. This is the logarithmic equation. It's given by t. Okay. What is the corresponding exponential equation, which is, we say base is always the base, right? So it would be 5, 12, 8 to the t. This is the exponential equivalent form. 4. Use a calculator. Okay, so you just use your calculator, right? And there is a log of, sorry. So this log means the base is 10. Okay, you can use the log button in your calculator directly, right? It would be, okay, in your screen, it should give you this number. Right? And it says, okay, the rounded your result to 5 decimal places, 5 decimal places. 1, 2, 3, 4, 5. Then you look at the 6th one, right? It's greater than 5 or less than 5, greater than equal to 5 or less than 5. So it's less than 5, no problem. We just ignore after that. So it would be, if it's greater than 5, greater than equal to 5, you need to round up. Okay. This would be your answer. Okay, so number 5. Number 5 is solve the equation for x. The equation is 2 to the 4x equals 2 to the 3 times x plus 5. Okay, so this is the exponential equation. So the first thing you need to do is you need to check if they have the same base, right? Okay, so here's this equation, very straightforward. They have the same base too. So the power should be equal, right? So you have 4x is equal to 3 times x plus 5. Okay, then we use the distribution law. We distribute 3 for each term. So it would be 4x equals 3x plus what? 15, yes. Then minus 3x on both sides. Okay, subtract 3x on both sides. Then what you have x equals 15. Okay. Number 6. The first one, which is without your calculator. What is log b to the 8? So what is the first step you should do? You bring down this power, right? 8 in front of the log, because this power is on the b, right? So it would be a times log b of b. What is log b of b? 1. So it would be a times 1, so which is a. So here's times. The second one, which is log 0.001. Okay, we know that log means what? The base is 10, right? If you just write down the log, the base is 10. So here is the 0.001 equals what? Equals 10 to the negative 3. Right. This is the idea, right? 10 to the negative 3. So then we can bring down this 10 and negative 3, the power negative 3 in front, times log 10. Log 10 equals what? 1, right? Because log 10 means log base 10 of 10. So it's equal to 1. So this one is equal to negative 3. The third one, natural log e to the 1. Okay, so the natural log, I mean, Ln means the natural log. Natural log is have the base what? Base e, right? Okay, so keep it in mind. So the same thing. This is the property we often use. Always bring this power in front. Okay, this is power in front. So this is the y times natural log of e. What is natural log of e? 1 again, right? Because natural log of e means log e of e, right? So this is equal to 1. Let's look at number 7. Number 7 is an application problem, which is about the exponential decay. Okay, then this one tells you the formula is n is equal to 40 times e to the negative 0.303t. This is the formula, right? N represents the number of the milligrams present after t days. So this is the radioactive substance. And we want to find the number of days it takes for 20 milligrams to remain. So that means n equals 20. Right? This problem tells you that n is at last, after t days, you have 20 milligrams left. So n equals 20. So we want to know what is t. Okay, so here t represents days. So we put 20 here. And we plug in everything, right? We plug in what we know. This is 20 equals 40 times e to the negative 0.03 t. All right. So this is the exponential equation, right? So what we should do for the first step? What is the first step we should do? We divide by 40. We divide by 40 on both sides, right? We divide by 40, so it would be 20 over 40, right? Which is 1/2, right? Equals e to the negative 0.03 t. Okay. So for our convenience, we just write down 1/2, right? Of course, you can just keep it and at last you input into your calculator, right? So okay. It's equal to 1/2. 20 over 40 equals 1/2. Equals e to the negative 0.03 t. Then what is the next step? We have talked this many times, right? Natural log. We take the natural log on both sides because we want to calculate the t, right? But t is in the power. So well, you need to calculate to find the t. So you need to bring down, right? So the only way is take the natural log, right? So natural log of 1/2 equals natural log e to the negative 0.03 t. So now we can bring down this power in front. Let's say 0.03 t times natural log of e. We know that the natural log of e equals 1, right? So it becomes natural log 1/2 equals 0.03 times t times 1. So what is t? T is equal to natural log 1/2 over negative 0.03, right? We divide by negative 0.03. Okay, so use your calculator. Use your calculator. It would be the sense rounded to the whole number. Okay, so that means we need the integers. So it should be equal to 23 days. Did you get it? 23 days. Okay. So this is the number 7. Number 8. Number 8 is to find the values without calculator. You cannot use the calculator because there is some letters, right? So this is the number 8, which is nature log 1 minus nature log e to the a. So this is the expression you need to calculate. What is nature log 1? I mean nature log 1. What is nature log 1? 0, yes, because all the logarithmic function will go through the point, which is that point, 1, 0 point, right? 1, 0 point, 1, 0 point, there is a point. The x-intercept is 1, 0 point. So when x equals 0, so here is 1. When x equals 1, so the whole nature log always be 0. Okay, so this is a very special value you should memorize. And minus, what we should do for the next term? Yeah, bring down a, nature log of e. Nature log of e equals 1 again, right? So it would be negative a. 0 minus a times 1, so it's negative a. Number 9. Use the properties of the logarithmic function to condense two times nature log of x plus nature log of y. Okay, so we use the properties. So the first thing is you cannot combine these two nature logs directly. The reason is we have some coefficient 2 here. By coefficient 2 here. We need to bring this coefficient inside the nature log, right? So we bring inside, it would be what? X squared. Yeah, x squared. Do you remember? We have, if we have the nature log, you can take the power in front. So the backward, we can take this number inside it, but it will go to the power. Okay. Then plus ln y. So now you can combine these two logarithmic functions, right? Use the properties. So which is nature log of what? X squared times y, not plus y, okay? Yeah, times y. So be careful. So this is this problem. 10. We want to solve this logarithmic equation. Log 4 of x plus 6 equals 2. We want to solve for this logarithmic equation. So how to solve it? The idea is we can use the equivalent exponential equation form. Okay, so this one means x plus 6 is equal to what? The equivalent form. 4 squared, yes. Right, the base is always the base, right? And you can see the number 3, we have told you this one, right? So x plus 6 equals 16. So x equals 10. Okay. So this is the number 10. Let's look at number 11, which is another logarithmic equation. Log b of x plus 3 plus log base b of x equals log b of 54. So what is the first step we should do? We need to condense the left side, right? Combine the two logarithmic function together. So if you combine the left side, it would be equal to log b of what? What's that? We just did here, right? If you have the sum, it would be the product, right? The inside will you multiply the inside, right? It becomes x plus 3 times x. Right, this is the inside. It's equal to log b of 54. So now the both sides are the logarithmic function with the same base b, right? So that means what? The inside should be equal, right? The inside should be equal, so which is x plus 3 times x equals 54. Right? Since they have the same base, same log, right? So the inside should be the same. This is property, right? So how to solve it? Expand it. So you have x squared plus 3x equals 54. Let's continue. What's that? X squared plus 3x minus 54 equals 0, right? Then we can use the factorization or quadratic formulas, right? But for our most problem, we just use the factorization. So how to factorize it? It would be x plus 9 times x minus 6 equals 0. If you don't know how to factorize it, you can use the quadratic formula to find two roots. Okay, so it gives you two roots. X equals -9 and x equals 6, right? So we have two roots, but for the logarithmic equation, one thing, as I said in class, you need to plug in back the solution you have to see if you can evaluate these numbers. So if you plug in -9, you can see here is negative number, right? Here, of course, is also negative. So we know that for the logarithmic function, this part always be positive, right? This part always be positive. So that means, but if you plug in 6, there's no problem. Okay, 6, there's no problem. But for -9, it will cause the problem. So -9 is not our solution. So we only have one solution, which is x equals 6. Okay, so now let's look at number number 12. Okay, number 12 is kind of easy problem. So this is convert the interest rate 1.6% to decimal. Okay, so this one would be 1.6 divided by 100. It would be 0.016. 13. Convert the decimal to percentage form. Okay. So it is 0.25 times 100%. It would be 25%. Okay. This percent means divided by 100. So you multiply 100 divided by 1, it will change nothing, right? This is actually 1. 100% is equal to 1, right? This is number 13. 14. 14 is the find the amount due on a loan, which is 8,500 at the percentage 7.5% simple interest rate. Simple interest. At the end of 4 years. So this is the problem, right? So after the end of the 4 years, what is the amount? So this one is, so here this problem tells you that P is equal to 8,500, right? And R is 7.5%, which is 0.075. And T is in years. This is 4 years, right? So our formula is I equals PRT, right? This is our formula. So now let's plug in everything times 0.075 times 4, right? So plug in everything, and you will see this number would be what? 2550. Is that correct? Okay. So, but this is not your answer. The problem asks you the amount due on a loan. So you needed to add to the principal. This is the interest you needed to pay, right? This is the interest you needed to pay. It's not the total money, right? So the total money A would be P principal time plus the interest, right? So this would be 8,500 plus 2,550, which is equal to 5,011. Right? Just double check. Yes. So this is your answer. So read the problem carefully. Okay, it asks you to find the interest of the final amount. Okay. Number 15. Number 15 is an investment. An investment of 12,000 or interest at an annual rate 7% compounded continuously. Find the value of the investment 10 years from now. Okay. So this is a continuous compound interest problem. So we needed to use the formula, which is A equals P times what? Do you remember that formula?
E to the RT.
Yeah, E to the RT. You needed to memorize this formula. The same thing for the simple interest rate. You also needed to memorize this formula. And this one, right? For the continuous compound interest, you needed to memorize this formula. So now our P equals what? 12,000 times E to the 7%. 7% is what? 0.07, right? 0.07 times t. T is what? T equals 10. Okay. So if you input this one directly, don't forget the parentheses for the power. Okay. Otherwise, you will multiply t on the previous result, not on the power. So then you will have this one is because it's about money, we always round it to 2 decimals to the cents. Okay, so this one would be 24165.03. Number 16, which is about the annual percentage yield. So APY, we need to calculate the APY. The annual interest rate, which is 6%. The first one, which is about the compounded semi-annually. What is the APY for this compound period, compounded semi-annually at an interest rate 6%? So APY represent a quantity like the simple interest rate. Okay, so it's easy for us to compare. So we know that APY for compounded interest, which is what? Which is 1 plus R over M to the M, right? Then minus 1. This is the formula. You also needed to memorize. Right, this is the formula you also needed to memorize. So let's plug in. So this is the 1 plus. What is R? R is 6%. So this is 0.06 over M. M is what? What is M? 2. Yes. So 2 to 2, right? Minus 1. Okay. Use your calculator. It would be 0.0609. So we needed to, at last, we needed to, APY is also a percent annual rate, kind of annual rate, right? So we also need to convert to the percentage form. So we multiply by 100 with 6.09%. So this is the first one. The second one, it says compounded quarterly. Okay, so the formula is still the same. 1 plus R over M to the M's power minus 1. But the only difference is what? The M is different. Now M equals what? 4, because it's quarter, right? 4 quarters a year, so it's 4. So here's 4. Minus 1. Let's keep the 3 decimals, okay? 3 decimals for the percent. So we needed to have 0.06136. Which is 6.136%. So how many decimals depends on the problem, okay? Three. Continuously, compound continuously. So we needed to use the APY for the continuous compound interest. So do you remember that formula? That formula is APY is equal to e to the r minus 1. It's very easy formula, right? You also needed to memorize this formula. This one is equal to e to the r is 0.06, right? 0.06 minus 1. Okay. Then you plug in, and at last you will have 0.06184. So it's equal to 0.184%. Okay, so this is the number 16. So the APY, you have two formulas. This is for the compound interest. This is for the continuous compound interest. Okay. Number 17. How long will it take for $3,000 to grow to 22,600 at an interest rate 3.1% if the interest is compounded continuously? Round the number of years to the nearest hundredths, so 2 decimals. Okay, so the formula we should use is for the compound interest, continuous compound interest, which is A is equal to P times E to the RT, right? So it asks you how many years. So it means you need to find the T values. Okay, so now we plug in everything we know. What is A? Okay, 22,600. What is P? 3,000 times E to the R is what? 0.031. Then times T. Okay, then we divide 3,000. Right? This equation we solved several times, right? You remember we have the number. Let me see which one we solved. A very similar one. Yes, I remember I just solved similar problem. So number 7, yes, number 7, right? Number 7, very similar, right? The format is similar. Of course, the problem is totally different. Okay, we divide by 3,000. Of course, you can simplify it, but my suggestion is just keep it. Maybe you can erase 2 zeros, no problem. That's no problem, right? Otherwise, because you cannot divide by 3 for the top, for the numerator, so you'd better to keep the fraction, okay, for the accuracy. Equal to e to the 0. So what we should do, we are looking for T. What we should do? Natural log, okay. For all this kind of problem, you always take the natural log.
So if you were looking for R, you would also use natural log as well.
Yes, as well, yes, the
Okay.
same thing. Because the thing you are looking for, which is in the numerator. No, you in the power. So you always take the natural log, bring down. Okay. Then we will have natural log. You bring down this one. Natural log. So my suggestion is don't take the natural log at the very beginning, okay? You need to simplify a little bit to have a single e with the coefficient which is 1. Then you can use the natural log. Of course, you can take the natural log at the very beginning, but you need to use other properties, okay? But this is my suggestion. It would be better to do this way to avoid some mistakes. So natural log of e equals 1, right? So you will have natural log 22600 over 3000 equals 0.031 t. So t is equal to natural log 22600 6000 over 0.031. Okay, use a calculator. Hundredths. So that means 2 decimals, which is about 65.14 years. Okay. Don't forget the parentheses here. Right. If you have no parentheses, you will have some trouble. So this is the number 17. Number 18. Number 18. Number 18 is it says if you pay $5,000 for a simple interest note that will be worth $6,000 in 21 months. What is the annual simple interest rate you will earn? Okay. So at the beginning, it would be $5,005. Then after 21 months, it would be 6,000. After 21 months. It asks you to find the simple interest rate, which is R equals 1. So simple interest rate, simple interest, simple. Simple interest, so we need to use the simple interest formula, right? So before that, this is our formula we need to use. P equals, sorry, not P. I equals P times R times T. Okay, so we need to figure out what are these numbers, right? P is very easy. P is equal to what? 5,000. R is the thing we are looking for. What is T? 21 months, right? But you remember in the formula, just T always used in years. Okay, so we needed to convert 21 months to years. How do we convert it? Divide by 12, right? Because 1 year have 12 months. So you can simplify a little bit. It would be what? 7/4. Or you can use the decimals, right? This is the years. Okay, so this is the T. So we have this one, we have this one, this is the thing we are looking for. So we also needed to know what is I. What is I? How do you get I? So at the beginning, it's 5,000. At the last, you will have 6,000. What is the interest you earn? 1,000, yes. So which is 6,000 minus 5,000, which is 1,000. Right? So we have everything, right? We just plug in. So this is 1,000 equals 5,000 times R. R is the thing we are looking for. Times P. P is 7/5. Okay. So if you 5,000 times 7/4, which is A750 over R, times R. So just multiply these two numbers. So R is equal to 1,000 divided by A750, which is what? Which is, let me see, 1 decimal place. Okay, 1 decimal place for the percentage. So this one would be 11.4%. 11, which is 0.114, right? So it's 11.4%. This is number 18. Number 19. Number 19 is a population. Follows the P represents population. Follows this formula, the growth of the population. Follow this one. Follow this formula. Okay, this is called exponential growth. T represents the number of years after 1988. Find the population in 1990. So what is T here? 2, right? Which is from 1988 to 1990. So this one would be 2 years. Okay, 2 years. Then we plug in. So this kind of exponential growth and exponential decay, this kind of problem, so far we are very simple. We just plug in the numbers. Okay, so P is equal to 100,000 times 1.03 to the 2. Then you use your calculator. It would be 1060,960. Number 20. Suppose $400 is invested at rate 6%, compounded semi-annual. Find the function for the amount of money after T years. It didn't give you the specific number for T. So you just keep the T. T is a given number. You just treat T as a constant. Okay. So this is compounded semi-annually. So we needed to use what? We needed to use this formula. A equals P times 1 plus R over M to the M times T, right? So this one is P is what? 400 times 1 plus R is 0.06 over M equals 2, right? And the 2T. Then you simplify, it's 400 times 1.03. You combine these two numbers to the 2T. That would be your answer. You don't need to plug in T. It's just say T years, right? This kind of problem just test your formula, right? Yeah. To avoid some calculation using a calculator. So this is number 20. 21. Suppose $5,000 is deposited in a saving account that earns 2% compounded monthly. What is the value of the account at the end of 5 years? Okay. So compound interest, this formula again, right? This formula again. So now our P is 5,000. 1 plus, this R is 0.02, right? 2% divided by 12. So the 12 times 5 years. When you plug in when you input in your calculator, don't forget the parentheses for the power, okay? So it would be, to save time, I just give you the answer. So 2 decimals, $5525.39. $22. A sample of 20 grams of radioactive substance decay according to the function. This is the exponential decay problem. This is the A of T. A means the remainder, okay, the remains after T, after time T. This is 20 times E to the negative 0.028 T. Okay, so this formula is given. This is decay formula. T is in hours, it said, okay. How many grams remain after 30 hours? After 30 hours, so that means T equals 30, right? So A is the remains. So A equals what? 20 times E to the negative 0.028 times 30. Okay, so use your calculator. It would be 8.634 grams. How many decimals depends on the problem. Okay, so here I just keep 3 decimals. $23. 10,000 invested is invested at 16% compounded quarterly. Quarterly. What is the balance after 6 years? Still using the formula directly. A is equal to P times 1 plus R over M to the N times P. Right. So this one is 10,000 times 1 plus 16% is 0.016. over quarterly, m equals 4, right? So this is the 4 times 6, so which is 2 decimals, okay? This is the button. That's last. 24 is a typical problem, typical exponential equations. We have this is the 300 equals 500 times 1 minus e to the t. 0.2t. Looking for t. Okay, find the t. So the first step, divided by 500 on both sides, right? So this one would be 300 divided by 500, which is 3 over 5. Is equal to 1 minus e to the next 0.2t. So at this stage, can you take the natural log? No, we needed to continue to simplify, right? We needed to continue to simplify. We what? It would be equal to e to the 0.2t is equal to what? 1 minus 3 over 5, right? So what you have? You have e to the 0.2t equals 2 over 5. Two over 5. So then after you get this one, you can take the natural log, right? Let's take the natural log on both sides. Natural log 2 over 5. Of course, you can write down as the 0.4. Okay, so this is the 0.2t times natural log of e equals. So now we bring down this power, right? Okay, so what we have, so natural log of e equals 1. Natural log of 1 equals 0, okay, keep in mind, what's up? What? Where is 0, 5?
No, I'm saying that's what we feel about, so it's real.
Which one? Which?
That looks like two, but
Which one?
that's
Just-
3 over 5.
3, yeah, is 1 subtract 3 over 5. Yeah, you can see. Yes, this one would be 2 over 5, not 3 over 5. Right. So it's 2 over 5 because you add e on both sides, then subtract the 3 over 5 on both sides, right? Okay. So this one would be 0.2t equals. This problem is a little bit complicated than the one we have solved, right? We just have this one here is an extra number, right? So, but you can still continue to simplify to the one we are interested in. If you can have this one, this kind of form, then you can take the natural log on both sides. So t equals natural log 2 over 5 of 0.2. Okay, so if the question asks you to give this form, multiple choice problem, for example, to ask you to give this form, the choice, you can, when you look at the choice, it's kind of this form, okay? So you're just using this form. Otherwise, you can calculate, okay? It would be negative 4.58. Okay, so this is the problem for the